We hear all the time about how AI is going to help doctors. But have you ever wondered what it actually takes to build one of these tools? To really look under the hood? On the surface, it sounds pretty simple, but the reality is a fascinating journey through some serious tech, ironclad safety rules, and a whole lot of responsibility. So let's dive in and see how it's really done. First off, to understand why this is so important, you have to start with a problem, and it's a big one. Doctors can spend 2 hours on paperwork for every single hour they spend with patients. Just think about that. This isn't just an annoyance, it's a major cause of physician burnout. It eats away at time for patient care, and it puts a huge strain on the entire healthcare system. And this is where technology comes in with this incredible promise. What if? What if we could just automate all that paperwork? Imagine an AI that just listens in on the appointment and writes up the clinical notes all by itself. That would free up doctors to, just be doctors. It sounds like the perfect solution, doesn't it? Well, here's the catch. The basic AI to do this, it's already here. But, and this is a huge but, going from a cool tech concept to a real, safe, and reliable tool that a doctor can actually trust with someone's health, well, that is a whole different ballgame. So let's break down how you actually build one of these, piece by piece. Okay, so the very first step is you have to get incredibly specific about the mission. Because in the world of medical AI, not all listening tools are the same. In fact, there are 2 really different ways to go about this, and telling them apart is absolutely critical. On one hand, you have dictation. The easiest way to think about this is like a smart microphone that replaces a keyboard. The doctor still has to think up and say the whole note, usually after the patient has left, and the software just types out exactly what they say, word for word. But then you have the ambient scribe, and this is a massive leap forward. This kind of AI just listens quietly to the natural conversation between the doctor and the patient. Its job is to then interpret that conversation and summarize it into a proper clinical note. See the difference? It's not just a typist anymore, it's an interpreter. And when you put them side by side, you can really see how the risk factor just explodes. With dictation, a mistake is pretty simple. It's a typo. But with an ambient scribe, the AI is making choices. It's deciding what's important enough to include, what to leave out, and that opens the door to way more serious problems, like missing a key symptom or even hallucinating, which is when the AI just makes up a fact that was never even mentioned. And remember, the goal isn't just to get a bunch of text on a page. To be useful, a clinical note needs to be structured. The most common way to do this is called a SOAP note. That stands for subjective, objective, assessment, and plan. So the AI has to be smart enough to hear this free-flowing, messy human conversation and neatly sort all the information into these 4 specific buckets. That structure is what makes the note actually usable for the rest of the medical team. Okay, so now that we know exactly what we're trying to build, we have to talk about the rules. And when you're dealing with healthcare, these aren't just suggestions. They are absolutely 100% non-negotiable. This is so important. The second a patient's voice is recorded during a visit, that audio file and the text that comes from it is considered protected health information, or PHI. And that triggers a whole universe of legal requirements. The entire system, from the microphone to the final note, has to be built with bank-level security and be fully compliant with strict privacy laws like HIPAA. And this number really says it all. When it comes to the critical stuff, we're talking medication names, dosages, patient allergies, the final diagnosis. What's the acceptable margin for error? It's not 1%. It's not even a tiny fraction of a percent. The target has to be 0. A single mistake here could be absolutely catastrophic. Which leads us to maybe the single most important safety rule in this whole process. The AI never writes the final note. It can't. The AI creates a draft. The physician is always the one in control. They are responsible for reviewing it, editing it, and ultimately signing off on it. They are the final author of record. Period. End of story. All right, so with our safety rules locked in, we can start talking about the tech itself. And one of the first, most fundamental decisions you have to make is, where does this AI actually live? Where does it do its work? Does the data stay locked down inside the hospital, or does it get sent out to the cloud? And you've basically got 3 main options here, and each one is a major trade-off. You could go fully local, meaning nothing ever leaves the hospital's own servers. That gives you maximum privacy, but it's a huge headache for the hospital's IT team. Or you could go fully cloud. You get the best, most powerful AI, and it's easy to manage, but you're trusting an outside company with that super sensitive patient data. And then there's a hybrid model, which tries to get the best of both worlds, but that creates its own set of complexities. So you've built the AI, it's secure, it writes a perfect note. You're done, right? Not even close. Now you have to face what a lot of developers in this space call the final boss of health tech: integration. It's one thing to create a great note. It's a completely different, and way harder, battle to actually get that note into the hospital's main software, the electronic health record, or EHR.
A good way to think about this is like a ladder. At the very bottom, the lowest rung, you have the clunkiest solution possible. The doctor literally has to copy the text from one window and paste it into another. As you climb the ladder, things get a little smarter, a little more automated, all the way up to the very top rung, the dream scenario, where the AI tool is just built right into the EHR software itself. It's completely seamless. But every single step up that ladder is a massive jump in technical difficulty, time, and money.
So what's the big takeaway here? It's that building a successful AI assistant for a doctor isn't just a coding problem. It's a systems problem. You have to be obsessed with safety. You have to navigate all the legal and privacy rules, and you have to have a realistic plan for wrestling with the messy reality of hospital software. The clever algorithm is just one piece of a much, much bigger puzzle. And all of this leaves us with one final, really big question. The AI technology is advancing at an incredible speed. It's here, it's powerful, and it gets better literally every day. The technology is ready. The real question is, are our complex, often slow-moving healthcare systems ready for it?